Hey, okay. I haven't recorded in a hot minute, and so I am trying to remember how to do everything. This box is kind of in the way. Whoa, I shrunk it down. Okay, so I didn't know I could do that. There. Okay. I'm just going to kind of move me. There we go. All right, so today's lesson is the constant rate of change, and you have your notes. And we are starting this unit. It's a pre-algebra unit, so you'll definitely use all the stuff in algebra, but talking about a constant rate of change. And a very most basic definition of rate of change is when two different rates change together. So first, let's get some vocabulary. A linear relationship is a relationship that has a graph that has a straight line. A graph that has a straight line. And so like a diagonal, or maybe it's going down a straight line, not necessarily horizontal, vertical, but we're going to be talking about linear relationships. And to know if something has a linear relationship, that means it has to have a constant rate of change. And the word constant means it stays the same. It doesn't change, even though it has the word change and rate of change. It's constantly changing at the same rate. And so the best definition I can give you for rate of change is 2 units changing same each time. Changing the same each time. So 2 units that are changing at the same time. I'm going to use the notation a delta, the letter delta, and it means change. Delta means change. So to find the rate of change, we have to know the change in the y value and look at that in comparison to the change in the x value. Change in y over change in x. And to find the change, you can subtract or you can just look for patterns. And so I'll try to show you both, subtracting or looking for patterns. But again, it's the change in y over the change in x. We're looking at how the y values, the units, whatever they are changing in the y, comparing them to the change in x. And so I have an example for you right here. Where's my camera? I have an example for you right here. So I'm going to move my box now to the top to kind of show you what I mean. So this example says the time to download songs. The time minutes is our x value. So 0 minutes, 1 minute, 2 minutes, 3 minutes, 4 minutes. And then the number of songs is our y value, 0 songs. So that should make sense. If you have 0 minutes, then you're going to obviously download 0 songs. In 1 minute, you can download 2 songs. In 2 minutes, you can download 4 songs. In 3 minutes, you can download 6 songs, and so forth. So here's our data in a table format. And I have a blank graph and then a question. So I am going to show you how to find the rate of change. And from our table, here's our data. We need to find the change in y's. And so our table is labeled for us, the change in y's. So how is it changing from each section? So we're looking for patterns. So from 0 to 2, plus 2, plus 2, plus 2, plus 2. You can see that. And then the change in x's is plus 1, plus 1, plus 1, plus 1. We could have subtracted 8 minus 6 is 2, 6 minus 4 is 2, 4 minus 2 is 2, but I'm pretty sure you see the pattern. So to find our change in y, we look at what happened every time, and you notice every time it was a constant change. So our change in y is 2 over our change in x, which is 1. And right now it's 2 over 1, which is 2. Now, that doesn't really mean anything to us until we put our units to it. That's what makes this a rate of change, because we need units to know what we're talking about. So our rate of change is 2. And what was the y value? Because the y went first, it went on top. So 2 songs for every 1 per minute. That is our rate of change. 2 songs every minute. All right, so now we can show you on a graph what that would look like by plotting these points. 0, 0 is our first point. 1, 2, 2, 4, 3, 6, and 4/8. All right, so I've plotted my graph. Now, I am just using the data on the table. I could connect these. I'm just going to lightly connect them, and you'd see this is a straight line. So this is a linear relationship because my rate of change is constant. My rate of change, it's changing the same. Every 1 minute, there's 2 songs, or 2 songs per minute. And I have a linear, I'm sorry, my nose is running. I have a linear relationship. So now my question says, how long will it take to download 9 songs? Well, you could look at the graph, but we haven't graphed it out that far, or we could use our information. And 2 songs per minute. So if we wanted to do 8 songs, that is 4 minutes. And if we wanted to do 10 songs, that would be 5 minutes. So 9 songs would be right in the middle, and so it would be 4.5 minutes. 4.5 minutes to download 9 songs. Okay, I'm just checking my time. I just want to look at it real quick. Okay. All right, so, whoa, yikes, sorry. Definitely zoomed in way too much. Okay. Now let's go on to our next example. The number of gallons of water remaining in a fish tank over time is shown. So we have gallons of water and time. Is the relationship between the number of gallons and the number of minutes linear? So we're trying to decide, is it linear? If so, determine the constant rate of change. If not, explain your reasoning. So in order for something to be linear, it has to have a constant rate of change. To find the rate of change, we need to find the change in y over the change in x. That's how you find the rate of change. And so hopefully if you hear the rate of change, you know change in y over change in x. So I'm going to just see if there is a pattern. So over here, it's +2 every time. 134, 118, 102, 86. It's not just coming to me, so I would subtract 86 minus 102, which really you would have to do 102 minus 86, and then this would be a negative 16, I think. 12 minus 6, 9, yeah, negative 16. And this is a negative 16, and then a negative 16. Notice my values are going down 16, so that's where I get a negative. And again, I found that because I subtracted 86 minus 102. And then you could have done 102 minus 118, 118 minus 134. So my change in y is negative 16, and my change in x is 2, which reduces to negative 8. Negative 8 is all fine and dandy, but it doesn't tell us anything about the water and the time, the gallons and the time. So I need to use units in your rate of change. You have to have units in your rates of change. So it's negative 8, and again, we start with our y. Okay, this is our x, this is our y. Negative 8 gallons per, so this was 2 over 1, so negative 8 gallons per minute. And that is my constant rate of change. And because it's constant, my answer is yes, it's linear, because constant rate of change. I'm going to abbreviate rate of change, and that's totally fine if you abbreviate rate of change. I don't know how to get rid of this box right here, so sorry if y'all can see that box. I'm not sure what I did to get that box, so we'll just ignore it. All right, so here we go. Another example at the bottom. Is the relationship linear? Start with the word linear. If so, determine the constant rate of change. If not, explain. So we have 2 more examples. Again, to find out if a relationship is linear, you have to find the rate of change, and is it constant? So I'm going to just do the x's. So this is +10, +10, +10. And it looks like my y values, so here's your x, here's your y. My y values are going down, so this is, when I subtract, I would get, this is 22, so this is negative 22. This is negative 20, and this is negative 24. 99 minus 123, so that would be 14. Yeah, negative 24. So, sorry, you can see my math a little bit down there. Let me just straighten this. So to find the constant rate of change, you compare your change in y over change in x. So for my first one, and you can probably see The 10s stay the same, but these do not stay the same. So if you show me this, that's enough to tell me that these are not linear because not constant rate of change. We can tell the 10s are the same. So if you were to set up negative 22 over 10, negative 20 over 10, negative 24 over 10, those are not going to be the same. So it's not linear because it doesn't have a constant rate of change. Let's do you try too. Or you try, pause it and you try. That's really what we should be doing for you try. This one is a graph, and so we need to look at the ordered pair. So this ordered pair is 8. What is that? Okay, let's see. This is 40, 50, 60, 70, 80. 880. Let me just make sure I'm doing that right. Yep. And then this is 1660. And this is 2440. So I have my ordered pair. If you need to put in a table, you can do that. 8, 16, 24, 80, 60, 40, X and Y. My X is number of volunteers, and my Y is the time. All right, so we are comparing. If you have volunteers, then obviously your time is decreasing because the more volunteers you have, the less time it takes. So I'm going to compare my change in Y over my change in X. My Y's are decreasing by 20, and my X's are adding 8 each time. So from the table, you can see, oh, it's changing the same each time, negative 20 over 8. So this would be linear. Is it linear? Yes. If so, determine the constant rate of change. So we need to find the constant rate of change. Negative 20 over 8 can reduce to negative 10 over 4, which can reduce, hey, good morning, to negative 5 over 2. And that is, no, don't come over. Negative 2.5. Negative 5 over 2. Negative 5 divided by 2 is 2.5. So negative 2.5 Y, remember, it's the change in Y. So negative 2.5 minutes per volunteer. So every extra volunteer you get, your time decreases by 2.5 minutes, which is nice. The more hands. We have a saying in our family. It is, many hands makes, Elle, can you finish it? Many hands makes, okay, never mind. She's sitting on the other side of the camera. She can't. Okay, many hands makes light work or less work. All right, so flip it to the back. Let me check my time because this could be, all right. On the back, proportional linear relationship. So now we have a new word, proportional. We've talked about linear, makes a straight line, it has a constant rate of change. Well, relationships can also be proportional if the ratios are constant. So I'm going to highlight this on mine. You can highlight that too. Now, the ratio is a little bit different than the rate of change. Compare the ratio, circle that or highlight that, Y over X, not the change in Y over the change in X, but just the ratio of Y over X. And I'll show you in a moment. Here's an example. Determine if there is a proportional linear relationship between the number of hours you rent a cotton candy machine and the total cost of renting the machine. Explain your reasoning. So to determine if something is linear, we need to know the rate of change. So I'm just going to put the word linear. To know if something is proportional, we need to look at the ratio. So we have to look at two different things. The rate of change is the change in Y, the change in X, and the ratio is just Y over X. So similar yet different. So let's do the rate of change first. It looks like the Y's are going up by 15 plus 15. And the X's are going up by 3. So the change would be 15 over 3, which is 5. So notice my change in Y's over my change in X, and it's 5. The Y's are cost of $5 per hour. So it is linear. Check. It is linear because I have a constant rate of change. Now let's check to see if it's proportional, meaning we check the ratio. I'm just going to take each ordered pair and we're going to check the ratio of Y's to X's. Now, if it has a 0, we don't want to check that because if you try to divide by 0, it's going to give you an error because you can't divide by 0. So we'll start with the next one. 40 over 3, 55 over 6, 70 over 9, and 85 over 12. And I got those from just looking at the ratio at y over x, y over x, y over x, y over x. And I want to compare them. So if I look for a moment and compare them, I could see 3 times 2 is 6. Is 40 times 2 55? And the answer is no. No. I could say 3 times 3 is 9. 40 times 3 is not. So these are not proportional. And when it says explain your reasoning, you would just say because ratios are not equal. Because the ratios are not equal. And so if you ever have an example when the ratios are not equal, that means it's not proportional. The ratios have to be equal. All right, so you can also check the graph if a graph is proportional. So this is different. You can also check the graph. Cost, hours rented. So does this right here go through the origin? Does it go through 0, 0? If it does not go through the origin, nope, not proportional. To be proportional, it must be a straight line, and it must go through the origin. So since this graph does not go through the origin, it is not proportional. I think you maybe did some of this in 7th grade. Okay, whoops, no. I'm gonna get this last one. Use the table to determine if use the table to determine if it's a proportional linear relationship between the mass of an object in kilograms and the weight of the object in pounds. Explain. So change in y over change in x and just y over x. We're going to check, and it looks like plus 9. Whoops, from here to here to here. And this is plus 20. So my change in y is 9 over 20. My change in y, 9 over 20. And it is linear because it changes the same each time. And it's 9 kilograms per 20 pounds. And then if you wanted to, I would use a calculator, but we could say it's, let's see, divide by 2, you get 4.5 over 10, which is 0.45. So 0.45 kilograms per pound. And I got that from simplifying 4.5 over 10. I divided them both by 2. And then when you divide by 10, you move 1 decimal over. Now let's check the ratios. So y over x. So 9 over 20, 18 over 40, 27 over 60, 36 over 80. And when I check my ratios, I see, okay, 20 times 2 is 40, 18 times, 2, 9 times 2 is 18. 20 times 3, 9 times 3. And I can see that all of my ratios, shh, y'all, please stop. I'm sorry, my kids are, no, he didn't. So all of my ratios are equal, which means yes, it is proportional. So this is linear and proportional. All right, sorry for that interruption. These notes, I know they were long, but we are going to go over constant rate of change. Is it linear? Is it proportional? And we're going to go over that in class soon.